The purpose of this video is not to solve all your issues, but just to talk about some common issues I'm seeing as we go through the exam process. So the three things I'm going to hit on are a little bit about slope-intercept form, solving absolute value equation inequalities, and adding and subtracting rational expressions. The first two are from the first test, and a lot of people have been taking that one. And then the last topic's from the fifth test. Most of y'all haven't gotten to, but some people have and have struggled a little bit with. Okay, so for the most part, we know that the number in front of x is a slope, and the number at the end is a y-intercept. So in this example right here, our slope is 3. We're missing a number at the end, so our y-intercept is 0. In this example right here, and this is one we have trouble with, this example right here, the 3 is not in front of x. The 3 is by itself. So this 3 right here is the number by itself, so that means our y-intercept is 3. So what's our slope? Well, we don't have a number multiplied by x. That would be 0x. So our slope is 0. This is the y in Hoy from Vux Hoy. Horizontal line, 0 slope, y equals 3 is how it's written. Obviously over here my slope is 3 and my y-intercept is 1. And all that leads me to one more point that has been an issue, and I thought my phrase, you can't stand on an egg, I thought we knew that, thought we talked about that, but let me try to clarify one more time. This right here is standing on an egg. The 5 would be you, the 0 would be the egg. You can't stand on an egg. This is not defined. But 0 or 5, if you put in your calculator, you get 0. Again, you put this in your calculator tells you 0. 0 divided by 100, 0. 100 divided by 0, the calculator is going to tell you error. Trust it. Okay. We're actually doing a really good job with this example right here. When people are doing it, they're writing x is greater than 5 or x is less than negative 5. Doing a great job with that. But then they solve this equation and we get x equals 5. If there's absolute value, I'm going to solve for the positive and the negative. So here I should have x equals 5 and x equals negative 5. So I'm doing the exact same thing. The only difference is here I'm going from greater than to less than. Here they're both equal to. But if it's absolute value, I'm going to get two sets of solutions. And then people are doing a good job multiplying and dividing with fractions and solving, and the adding and subtracting is giving us an issue. I'm not going to focus on getting the common denominator. I'm hoping we know how to get that. So our common denominator, and once I write this, I will not touch it again. Let me repeat that. Once I get a common denominator, I will only copy the denominator the rest of the process. My issue is compensating in the numerator. Again, compare this denominator to my common denominator. It's pretty obvious that the first denominator is missing the x minus 3. You see, I multiplied, the bottom already had x plus 2. I basically multiplied the bottom and the top by x minus 3. Now, compare this denominator to the common denominator. We're missing x plus 2. So I need to multiply the top by x plus 2. Here I am multiplying the top by x plus 2. I will not reduce. I cannot reduce because I'm adding. My goal is to add, not reduce, add. So I will copy down my denominator in order to add in the numerator, but before I add, I actually have to multiply. So x minus 3 and 3x plus 6. Combine my like terms, 4x plus 3. And once again, I simply copy down my denominator. If you made it to this far of the video, understand the purpose, again, was to help you, and you're still welcome to ask any questions.